Good morning. This is my fourth class on the chapter Therapeutics. Today's topic is erythrocytes and its disease. Now, erythrocytes. Erythrocytes are circular, biconcave, disc-shaped cell. They are very minute, having a diameter of 7.2 microns. Erythrocytes do not have a nucleus, but they have a respiratory pigments called hemoglobin. The red color of blood is due to the hemoglobin. In blood, the normal RBC count is 4.2 to 6.2 million per cu RBC are produced in the bone marrow of spongy bone, which is present at the end of long and short bones. Protein, iron, vitamin B12, folic acid, thyroxine, trace amount of copper and manganese are required for the synthesis of erythrocytes or red blood corpuscles. The average lifespan of erythrocyte is about 120 days. Now, the function of RBC or erythrocytes. RBC helps to transport oxygen from lungs to tissue as a oxyhemoglobin, and similarly RBC transport carbon dioxide from tissue to lungs as a carboxyhemoglobin. Hemoglobin acts as a buffer and regulates the hydrogen ion concentration, and it's maintain acid base balance in blood. RBC carries the blood group antigen and Rh factor. Now, disease associated with erythrocytes. There are 6 types of disease which is associated with erythrocytes. Those are polycythemia, iron deficiency anemia, megaloblastic anemia, sickle cell anemia, hemolytic anemia, and thalassemia. Now, polycythemia. Polycythemia is a disease characterized by increase in the number of red blood cells. The causes of polycythemia are high altitude, congenital heart disease, and manifestation of polycythemia are headache, weakness, tiredness, red eyes, red face, etc. Now, the second disease is iron deficiency anemia. It is also called as microcytic anemia. The defect is a decreased hemoglobin content in RBC. For the synthesis of hemoglobin, iron is necessary. So, this type of anemia occur due to the deficiency of iron. Next is megaloblastic anemia. It is called as macrocytes anemia. This type of anemia occur due to a defect in the manufacturation of RBC. For the maturation RBC, both vitamin B12 and folic acid are necessary. So this type of anemia occur due to the deficiency of vitamin B12 and folic acid. Now the next disorder is sickle cell anemia. It is a hereditary disease. It occurs due to the presence of an abnormal hemoglobin called HbS. It differs from the normal hemoglobin HbA by the presence of valine instead of glutamic acid in the beta chain of globin. RBC contain HbS on deoxygenation assume a sickle shape. This abnormal RBC cannot pass through small blood capillaries, so they block these capillaries. This results in loss of blood supply to vital organ and their damage. Sickle cell patients have a marked susceptibility for infection. Now, the next is hemolytic anemia. Hemolytic anemia are produced due to the destruction of RBC and the consequent liberation of hemoglobin. Hemolytic anemia leads to hemoglobinemia and jaundice. Now, the next disease is thalassemia. It is a genetic disorder of hemoglobin synthesis. It occurs due to the decrease in the synthesis of either alpha or beta globin chain of hemoglobin. In alpha thalassemia, there is a decreased synthesis of alpha chain, or in beta thalassemia, there is a decreased synthesis of beta chain. Beta thalassemia is common than alpha thalassemia. The manifestation of beta thalassemia are severe growth retardation, distorted and large size face, enlargement of liver and spleen, delayed sexual development. The beta thalassemia patient die early, around 17 years of age. Blood transfusion can delay the death of some extent. Thank you. And in the next class, we discuss about leukocyte.